So data analysis using statistics is our next topic. So I'll close this one now and open data analysis. So data analysis, yeah. So things that you were seeing in Python, and few things that you might have seen in Excel, and you might have seen in SQL as well. Everything is possible to do in Excel as well. Not everything, but most of the things are possible to do in Excel as well. So I just kept a simple small data, basically a temperature, price of ice cream, and units sold. Okay. So basically this is a data in which, like, at what temperature, I mean environmental temperature, what is the price of ice cream and how many units are sold, basically. Nothing too fancy, but just to give you an idea that what is happening here in the data analysis part when you're doing in Excel. So let's go ahead and jump the content that we have. So data analysis is done in Excel as well using a tool, basically, which is there in the data tab. So when you click on data, okay, you'll see a tool called data analysis. Okay, this is one of the analysis tools. There's another called solver, which is used to solve non-linear or linear programming, not non-linear. But data analysis is something which is basically used for performing those statistical checks, statistical methods that you apply on top of the data. And you just have to click on data tab, and if that data analysis does not appear, then you have to go to Excel file, and then options, and then Excel add-ins, and then go. Okay, when you click on go, you'll have the option of analysis tool pack, VBA analysis, euro currency tools, and solver add-in. Okay, I've selected analysis tool pack and solver add-in both. You can just restrict it to analysis tool pack if you don't need solver add-in right now. Okay. It's basically for a linear programming method, and basically if we discuss that, then we'll go to the beginning of machine learning, so we'll avoid that and just restrict it to analysis tool pack. And if you click on OK after this, then this will appear on your data. If it doesn't appear, just restart your Excel, and then it will just close the Excel files, and then open it again, and then it will definitely appear. Okay. So check once. If it doesn't, then let me know. I'll check what's the issue, but it should appear in your data tab. Yeah. So again, a very small data with temperature, price of ice cream, and unit sold to explain everything. Okay. When you select the data, okay, and go to data analysis, and then go to descriptive statistics. Click on descriptive statistics. Click on OK. Then what you'll see is you'll see an option of A1 to C8, which is selected from A1 to C8. There's an option of labels in the first row. If you don't click that, it will not identify that first row as your label. It will try to identify it as a number, and that will be a problem. Okay, because it won't give you the solution. And then I've selected output range. You can select anything. I'll just remove it and showcase it to you here. Select the output range here, okay, E27. Summary of statistics, 95% confidence interval, okay, and click on OK. See, you'll get the same thing which I already have created, but yeah, just to showcase that things that we want to try here, you can do that. There's another confidence interval level that I didn't try it before, but is there. So that part has been added. It just gives you confidence level from the 95th percentile, which data starts from there. That's all. But these information, like you can get, these are the same information that you get when you suppose put this data in your Python Jupyter notebook or whatever notebook ID you're using. Okay, and you put it in a data frame, suppose df, and when you write df.describe, okay, then the same information comes up, and this is the same information that you can get from data analysis tool pack. in Excel as well. You just have to type descriptive statistics, click on OK, give the range, input range, put labels in the first row. If not, then don't start from A2 and finish it at C8. So A2 to C8, then you can remove the labels in the first row. But I keep labels as well, because if you remove that, then these things won't come. Price of ice cream, units sold, temperature, these things won't come. It will mark it as label 1, label 2, label 3. That's all. So that's what happens. If you want to remove the summary of statistics, you can remove that as well. Confidence level of mean, and if you want to put kth, largest, kth, smallest, things like that. If you want to put not in the output range where in the same sheet, if you want to put it in the new worksheet, you can put that as well and apply and give the option of the new worksheet separately. If you want to put it in the new workbook, you can do that as well. It will just open a new Excel sheet for you and give all the values there. But I mean, it's better to put it right in front of your data, and so that if you want to compare it and see what's happening, then you can do it. I'm not going to go into details of mean, median, standard deviation, things like that, variance. You already have covered that part in your statistics class. It's just that you can get all the information from Excel using the descriptive stats option that you have in data analysis toolbar, right? I'll just keep both of them. Any doubts on this one? Cool. Now, moving on to sampling. So there are two types of sampling that we can perform using Excel. There's one is periodic sampling and the other one is random sampling. So what happens here is, like when you try to do sampling, there are methods, there are different things that you can try. So basically, when you're trying to sample data, like take a subsample of the data, you can take it randomly from here as well. But if it is a very large data, I've kept it small, but if it's, imagine if it's a very large data, then it will be difficult to just copy paste and select it randomly or periodically or things like that. Okay, so Excel gives you that option to use it periodically or take data from random sampling as well. So I'm just taking the sample of temperature. Okay, so when you do that, go to again data and data analysis toolpack, and then click on sampling, click on OK. Okay, and then if you want, you can generate it for, I've generated for B1 to B8. Okay, if you want, you can take it for temperature. So let's do that, T2 to T8. Okay, let's select label as well. So A1 to A8, sorry, and put labels as well. And then let's see, let's try periodic first and put 2 as our period number. Okay, and the output range, let's just remove G7 from here and put the output range, so that number will be visible here. Okay, and click on OK. Okay, it will be the exactly same number, 26, 35, 40, because it is taking the numbers 26, 35, and 40, because it is we have given it the period 2, so it will just leave the first number and take the second number. Okay, again leave the first number and take the second number. So 2 period wise it will do the periodic sampling. Okay, now for random sampling, you again go to the data analysis toolpack, click on sampling. Instead of the periodic sampling, okay, you can select random here. Okay, and number of samples if you want. So I've just kept it 3. Let's keep it to 3. And the output range, we'll just put it here in F12, and let's see. So as you can see, for periodic sample, when we did it in before, 26, 35, 40 gave the period 2, 26, 35, 40 is the same number. For random sampling is 36, 26, 35. Here it is 35, 38, 30. Okay, it's not giving me the exact number because now we are using random sampling. So it makes sense that it will give you a random number every single time. Okay. So any doubts on this one? I mean, it's for a small data, but you can understand when you are trying to analyze data and create subset using specifically random sampling, how useful it can be for you to analyze the data and do statistical checks on that. So I'm showing you a bigger picture by giving you a small example. So any doubts on this one?
So here periodic sampling is simply like systematic sampling in stats, right?
Yes, exactly. Yeah, exactly.
Okay. So it is working in the same way as it do in the Python, the
Yes.
background internally.
Yeah, exactly the same way. It is also like designed using multiple thousands of lines of code. It's just that
Okay.
it's a tool. Excel is a tool, and it gives you the option of selecting frequency. Obviously, in Python, you can do multiple other things as well, but and it is very much straightforward, and there are limited options. And obviously, if you write your own code, you can do multiple other things. But yeah, for periodic sampling, you'll have the option to select the number of period. For random sampling, you'll have the option of number of samples that you want to select, and it will, within the data, it will give you the number of samples you want randomly.
So okay. So basically, we can say that we have a something called generic code for Excel as well as for Python as well.
Yeah.
They have written in Python. It's written in document format, and it's written in here something in Excel format, coding format,
Uh,
something.
uh, in which format it has written, I am not sure about that. Like what languages they have used to write the background, the backend of Excel. But yeah, if it is selecting the same data from your existing data frame, basically this is data
Mm-hmm.
table in Excel. It will be a
Okay.
data frame for you in Python. And if you want to do sampling, you can just periodic sampling. You can just select the frequency is equal to 2, and then the number of sample equal to 3, and then write down the code for it in Python, and you'll get the exact same number. And for random, if you create random numbers, then obviously
Okay.
there's
Okay.
a backend code for that, and it won't generate you the same numbers every time. So it's the same thing. It's just that in Excel it is a bit easier, but with limited options.
Okay. Right. Like the limitation in the size of our data.
Uh, yeah, that's one of the limitation. But I mean,
Okay.
with in Excel, like you can give the number of samples as 3, and like in here, and you can only give a frequency and things like that. In Python, you can perform some mathematical operations on that as well. So if you want to take sample and then perform some mathematical operations on top of that within the same line of code, you can do that. But here, using analysis tool pack, you cannot do that, right? No mathematical operations on top of it. Now when once you have found this data, now you can
Mm-hmm.
do any other operation. So basically it will mean the same. It's just that one work is dragged to two different parts and things like that. But in Python, sorry, you can do all together in one go, writing 1 2 lines of code. So that's the difference.
Okay. Okay. Got it.
Okay,
Yeah.
cool. Any other doubt? Cool. Moving on to histogram. So histogram is basically now I have just kept temperature for this one. So and I have just increased the number of values as well, and I've given some bins. Okay. So now once you're trying to build up histogram, so what's happening here is uh, you select the data and go to data analysis again. So everything we are doing is for data analysis toolpack, from data analysis toolpack, and then click on histogram. Okay, click on OK. So there's difference. As you can see, I have created 2 different histograms. In one, you are seeing bin frequency, and then again histogram has been created. Okay, the numbers are same, like it is 5332. Obviously it will be the same, but here you can see a cumulative frequency that has been generated, cumulative percentage. Okay, but here there's not, it's not there. And both has chart, but one is basically just a simple chart with no cumulative percentage, and this one is having cumulative percentage. So you can uncheck that and create a cumulative percentage if you want, and if you don't want, and if you want, just check on cumulative percentage. Basically what is happening here is it is creating a histogram on certain bins. Okay, so my data is this 2246. Okay, A1 to A14. It is having labels. Okay, so that's why it is able to identify that it is having the first row as label, and then basically it is taking bins. So I'm dividing it into 4 different bins: 20, 30, 40, 50. So it is identifying as 20, 30, 40, 50 as bins. So C4 to C8, I'm locking that. And then output range, I'm just kept it to U6. You can change it if you want to regenerate it, and it will be the exact replica of this particular bit. And if I remove the cumulative percentage, it will be exact replica of this particular bit. Let's just see. Click on OK, and as you can see, it is the exact replica of this particular bit. Bins has been created, frequency, cumulative percentage, and then again cumulative percentage it is showing, and then it is just giving you the chart as well. And this is very handy for those who want to showcase that how your data is performing. Even if you want to see your histogram as a normal distribution curve, then also sometimes if it's normally distributed, it will showcase it to you like that, and you'll be able to identify certain things as well. So just to create histogram, you have the option to do that. Obviously, you can do the same thing in Python. It's just that Excel has that functionality. Okay. The same thing, I'll just remove that. Okay, any doubts on this one or this one, anyone?
Why
Same
we
thing.
are having 2 bins in that table that is coming with the this histogram picture?
Okay, this one. Okay.
Right.
So basically what we are seeing here is it's dividing, it's just keeping it simple: 20, 30, 40, 50, and the frequency of it. Okay, now what we are seeing here is 40, 30, 50, 20. Okay, and you can see 40. Okay, so it has been sorted in the form of frequency, so that's why it is coming twice here, just to sort this. So histogram, when it will create a chart, then it will identify these two columns as their data source, and what it will do is it will create a chart from sorting the numbers from these two columns. Identifying is 40, 30, 50, 20, 40, 30, 50, 20, and then frequency is 5332. Okay, sorry, I thought it is pretty much straightforward, so that's why I didn't explain that. Yeah.
Okay. Yeah.
Cool. Any other
Yes.
doubt? As you can see, if you can, how to confirm that these two are the data source for it. If you click on the chart, these two columns are highlighted. So you can see that these two are its data source. Even it is taking more, we can just remove that as well and restrict it to 40, 30, 50, 20, and so that it doesn't take more and generate the histogram like this. Okay.
Can the beans be selected automatically?
Bins automatically, no, you have to give the bins. So yeah, that's the difference. So if you're generating histogram in Python, you don't have to give the bins, I think. Yeah, you don't, but here in Excel you have to give the bins.
Okay.
But it gives you the option to control your bins as well, right? You can generate numbers as per the frequency, so like that also. Okay, but yeah, I mean, it works like this as well. So if you want 10, 20, 30, 40, okay, let's do this. So if you want to generate like this, and once it is identified as that it is counting on a frequency of 10, like 10, 20, 30, 40, it is increasing by 10, incremental frequency of 10, then you can select all the 4 cells, and then if you drag it and move it forward, then it will identify that it has to move 10 points beyond in each cell. Okay, so it won't give you any other random number. It will identify the frequency. So it is also smart enough. You just have to drag and drop, and if you want more bins, you can do that. Okay, so yeah, just to confirm, this is the data set that it is capturing, not this particular bit. Okay, right. Now moving on to correlation. So correlation is again a very important topic for every data scientist. So you have to see the correlation between data before applying it to any machine learning algorithm, or basically even if you want to explain anything to your client, trust me, when you go into industry and when when you'll try to explain it to your clients, the only statistical, maybe other one is percentage difference, but the only statistical term that they understand is correlation, not even covariance, not even nothing else. They understand correlation very well. So this is the one tool, this is the one basic identifier that you can use as your translating method to them. So they won't understand what is happening. They don't understand sampling. They don't understand descriptive statistic, mean, median, mode. You have to reiterate them. If you talk about standard deviation and variance, they will go to some other world. So but they do understand correlation. So every time, and it's very important interview question also, how do you communicate with your client? They will definitely ask in every interview, in every round, how do you communicate your data with your client? So use this particular bit in every interview, and that will give them the confidence that yeah, you have talked to the clients and you understand the problems of stakeholders. So whenever they will ask you that what how do you talk to a client, how do you solve their problems, how do you relate your data to them, so you just have to explain it in one line that whenever I see the data and whenever I want to highlight something unique or highlight a problem within the data, I try to communicate it with them, showing it through different tables, and I also try to use a statistical method to convince them statistically. So I use correlation, which they generally understand very well, and they do understand correlation very well, all the business managers and everyone. So that gives them the confidence that yeah, that you have worked in the industry. So that, I mean, small things give them the confidence, right? So this is one of the things. So use this as your tool, this and percentage difference, to give them the identifier of the data. Again, so a little bit off track, but it is important for your interviews. So same data.
Thank
Now,
you, Role,
if you
for
select,
sharing.
no worries at all. I think I'll take one of the session for your interviews as well, because have I've taken a lot of interviews. I have given a lot of interviews in multiple countries now as well. So it will be very handy for you guys to keep I'll ask from the management. I'll keep a session for the interviews. I'll discuss some of the interviews. And if you're like well prepared, just ping me once. Like if you feel that you're well prepared as well, just ping me once. I'll try to arrange a session. I mean, not one to one, but at least 2, 3 guys all together, and I'll keep a 1 hour session and we'll take a mock interview session, so that you'll feel prepared enough. Okay, cool. Yeah. So no worries. And yeah, so we have data again, same thing, temperature, price of ice cream units sold, and we go to data analysis, and then we have to find correlation. Okay, so correlation is, yeah, click on correlation. Okay, again, the data is the same, A1 to C8, labels in the first row, taking columns as group by, and output range. Click on any value here if you want, and then click on OK. Same number, there's no difference. I mean, there might be some difference at the very end, but yeah, most of it would be the same. Okay. Cool. So as you can see, when you generate correlation in Python, it's very simple. .core function you use, but it will be the same thing. Temperature to temperature, it will be 1. Ice cream, price of ice cream to price of ice cream will be 1. And unit sold to unit sold will be 1. Cool. Now, this is just an indication of temperature. Basically, it is identifying temperature as probably Y, so it was giving like this. But ignoring that, you can see that what we are getting here is price of ice cream and temperature is basically very highly correlated, but unit sold with temperature is not at all very correlated, or unit sold is not correlated with the price of ice cream. But price of ice cream is correlated with temperature, and you can see that, identify that as well. So 20 temperature was 10 pound, 26, 10, 20 pound, 30, 25 pound, things like. When temperature increases, the price of ice cream is also increasing. So that's why the correlation is 96%, basically 0.96. It is nothing but Pearson coefficient of correlation. Okay, no worries, Meher. So yeah, that's the thing. So again, same thing, data analysis, go to correlation, select your data range, and labels in first row, and just give the output range, and it will give you the values. Again, if you don't select this labels in the first row, it won't identify the first row as your string or object type, and it will try to identify it as numeric value, but it won't get it, and it won't show you the correlation. So if you want, you can check that. So if I've removed this labels in the first row and kept A1 to C8, the entire data, then click on OK. Let's see. Correlation input range contains non-numeric data. So it will give you an alert and won't give you the correlation value, right? So you need to put the labels in the first row. Okay, so any doubt in the correlation bit? Cool. Now moving on to covariance. So again, covariance is basically statistically, the relation between two particular variables. Basically, we try to use it on two independent variables. So then we are trying to identify the covariance between two different variables. Then you can go ahead and try it on data analysis toolpack again, select the data for, I've selected for price of ice cream and units sold, and then go to covariance just below the correlation, select the data, B1 to C8, it has been selected, and labels in the first row again. And then that's again, it's important to put labels in the first row, and then remove the output range and put it here, and then click on OK. It will give you the same values as you are getting, as I've already done. And this shows that the correlation between price of ice cream and price of ice cream is high. Obviously, unit sold to unit sold is high, but they within themselves the correlation is not very high. So yeah, but with temperature it would obviously give another picture. As we can see, I mean, correlation is high, so covariance probably would be high, because with increase in temperature, the price of ice cream was increasing as well. So very simple covariance. You can simply check it in the Python code as well. So there is a Python code for covariance as well, .cov, I think. Maybe I'm missing, but yeah, there is there. Direct function from pandas. You can use that and replicate the same thing if you want to try. But you can do the same thing in Excel as well. So that's there. I mean, just out of curiosity, I wanted to ask, did you guys know that these statistical checks you can perform on Excel as well, or you already knew and you're just seeing it right now after a few days or few months or something like that? Have you tried it in industry?
Yeah, no, we did not try it, but we just know that like we can draw charts. But this is the first time like we'll be practicing practically.
Okay, cool.
We
Yeah.
are doing
So,
doing in Python just for practice.
Yeah.
But for the Excel we are seeing it the first time. This is very
Okay.
good.
Cool. Yeah. So in Excel, it's very straightforward, simple. It's just that you have to have this data analysis tool pack, and for small data set, it is very handy. And in Python, you won't sometimes get the feel of the data, and in Excel, you will get the feel of the data. To be very honest with you, so I mean, I don't know if I'm a very good data scientist or not, but whatever I am, I because of I know Excel and I know how to visualize data in Excel. So data scientist is a good data scientist. Every data scientist who is a good data scientist is basically because they know how to draw patterns in data and know how to visualize data. Okay, and obviously programming languages make your life easier, but if you take subsample of that data, so suppose my go-to method would be like, even if I have millions of rows, I'll just take random sample of data, subset using Python, and try to find pattern in those subsets, and do some statistical checks to do some data analysis. It gives me better feel, and then replicate it within the with the code. Obviously it will take some more time, but it will give you more confidence that what you have to do in the future. So if I'm seeing that it is heavily correlated with temperature and price of ice cream, obviously I'll have to drop one of them if we have multiple rows, right? So that's the thing. Okay, so moving on to Ttest again. You can perform Ttest in Excel as well. You can perform Z-test as well. I've just kept Ttest. Again, same thing. If you want to perform it on two different pairs, so you can do that. Let's just keep it to price of ice cream and units sold, and data analysis tool pack. Again, you have Ttest paired for two sample for means. You can try others as well. There's a Z-test for two sample means as well. Equal variances and equal variances as well. You can try that. I'll just showcase Ttest for you. And then again, the variable range of first one and the variable range of second one. So initially I did for A2 and B2, let's just do it for A2, B2 again. And then hypothesized mean difference, you can put, I've just kept it mean difference as 10. You can put it any other number, it's your hypothesis, whatever you want to put, whatever unique identifier basically it is there to identify between two different samples. So it will compare the mean value as Ttest concept today suggests. So you can put it any number if you want, and then alpha 0.05. It is just giving me 95% confidence interval. Yeah, I'll just keep A1 and B1 and put labels so that it gives me, instead of variable 1, variable 2, as you can see, initially I didn't put it, so it is giving me variable 1 and variable 2. Now it will give me the variable names. Okay, and click on OK. I think okay. B1 to B8. Okay. Yeah. So now it has basically overwritten it. I should have kept it separate to showcase it to you guys. Let's put it here. And then, okay, cool. So now instead of, okay, it has overwritten already. Hold on. Let's remove the labels, put it here. Put it A2 and then B2. Click on OK. Variable 1, variable 2, and just remove this. Okay. And then if you do data analysis, the same thing. Click on labels, select from A1 to B1, click on OK. It will give you the same numbers, just that variable 1 and variable 2 has been replaced from temperature and ice cream. So it's important to just give the label name and take the values. So again, it will give you mean, variance, and then it will give you the paired two sample of for means. Okay, and then again, you already know what P and T critical means from the Ttest. It's just that the comparison of temperature and price of ice cream that we are doing. That's all. And again, you'll get the Pearson correlation coefficient and things like that when you compare, and yeah, all the other information that you get from Ttest when you do it on Python or R as well. Same thing. It's just that you have to go to data analysis tool again, select Ttest paired for two sample means again, and then you perform the analysis. You can do ANOVA as well here. Okay, so ANOVA can be performed on multiple columns, okay, multiple variables, okay. You have the option of performing it within the group and between the group as well, okay, if you are selecting two different ANOVA. And how we do it is, again, going to the data analysis tool pack and doing it for ANOVA. I've used single factor. You can use two factor with replication as well, or whatever. And then identify this as data. So I've kept B2 to C8. And so I'm just using price of ice cream and units sold and keeping it as column. Again, alpha 95% confidence interval. I haven't kept the labels for this as well, unfortunately. A1 to C8. Yeah. And then put labels in the first row and then click on OK. And then it will give me the values for all the three columns. Okay. Temperature, product of price of ice cream and units sold, and the count, sum, average, variance, and then the main things, the statistical measures that we calculate from ANOVA. Okay. And obviously the F critical, which is the identifying factor for rejecting or accepting the null hypothesis. Okay. And the p-value as well, if you want. Cool. So this for single factor ANOVA. Any doubts on this one or on Ttest? I mean, not statistical doubts, anything related to Excel. Or even if you have statistical doubts, you can ask. It's not a problem.
Like we have studied the group by row, right?
Group by row.
In correlation.
Yeah.
What is the meaning for that? Is any benefit for it?
Correlation. Okay, between groups and within groups, are you asking like this for this
No,
one?
in the correlation correlation topic.
Okay.
Actually, my internet was not okay at that time.
Oh, okay. So correlation is basically giving you the Pearson coefficient correlation. Okay. So for temperature and product of ice cream, it is showing is 96 and others are not very good. Okay. So
yeah, during the selection of correlation, can you go to it, data analysis?
Correlation. Okay.
And in the group by row, there is a group by column and rows.
Yeah.
So
if you
are
do
we using that portion?
No, we are not using it because if you do rows, what it will do is it will compare these things. Okay. What it has to do it has to compare these things. So if it has to compare all the numbers from temperature and the numbers from price of ice cream, then all the numbers
Okay. Then it will compare by itself, and then there will be no use.
Exactly.
Okay. Yeah.
Cool. So ANOVA is done. Any doubt on covariance, Ttest, and ANOVA until this point? Cool. Thank you. Moving on to moving average. Yeah. So moving average is basically, again, you might be knowing it, but moving average is a time series algorithm, one of the algorithms of time series. Okay.
Right.
That also you can do it in Excel, surprisingly. Again, you have to just select data analysis. Okay.
Very easy to do these kind of tests.
Yeah.
Because in Python, we have to remember the libraries, we have to see the options.
Yeah,
so
exactly.
It is very handy.
Yeah, it's very handy. That's what I'm saying.
Yeah.
For small data set, it's very handy. Or even if you have large data set, just use Python to capture a smaller data subset and then use Excel to perform the analysis. Like it's for your own benefit. You will learn better doing it in Excel. And then obviously, again, Python is just a coding language. It's better to become better in data first, right? So yeah, moving average again, obviously it's a moving average. So it will obviously use just one column. So it will just use one column to generate the moving average for the data. You can put interval as 1 to whatever, more than 1 basically, because the concept says that it will take at least the average of 2 values. So yeah, at least interval of 2. And then output range, I'll just remove the output range and keep it here. Okay. And if you want chart output as well, you can get it. If you don't want, you can remove that. If you want standard errors, you can do that. If you don't, remove that. Click on OK. It will generate values exactly the same for this. And you can see in the graph, because obviously the first point will be 0. I mean, it won't be identified because it won't get a value before 12. So obviously it won't get that, but it will take an average of 12, 15, and then it will again take moving average of 13 and 15, and then things like that. Sorry, 10 and 15, and then again 20 and 15, and things like that. It will increase. So now if you want to compare how your actual and moving average looks uh, like so you can see that it is pretty much in line with your actual data. So if you want to predict future using moving average as well, it will give you an indication that yeah, it can be a good thing using a simple moving average for your data instead of going for any fancy algorithm. Okay, so it can be a good identifier for you. Cool. Any doubt on this one, moving average? Nice. Moving on to regression. Now, again, you have the option to do linear regression as well in Excel. So it is actually linear regression, and now it will take independent and dependent variables both. So again, go to data analysis, go to regression, click on OK, and then you have the option of input by range. So input, I have kept units sold. Okay, C2 to C8. I'll just put labels as well. Okay, and put C1. Oops. That's the only problem. C1 and then A1. Okay, and then put labels, and yeah, confidence level 95%, obviously. And if you want to put it in the output range here, you can put it here. If you want standardized residuals as well, it will generate one more plot. I've just kept it 3 plots. If you want, you can do that. If you want normal probability plots, let's just see everything. Okay, you have the option of seeing everything. I mean, for this, I don't know how many lines of code you have to write in Excel, sorry, in Python. But yeah, here you can just click on these things and you'll get the values. So you have the data with you. The independent variables are both A1 and B, A to B. So I've kept it A as temperature and B as a price of ice cream. Both are considered as an independent variable, and your Y range, basically your dependent variable, is C1 to C8, basically units sold, and output range is basically where you want your output. So I've kept it E41. I'm getting residuals, standard residuals, residual plots, line fit plots, and normal probability plots as well. Click on OK. Immediately it has generated a result. You can see that you're getting R square as 45, multiple R 67, adjusted R 0.17, standard error 5.2, it's a bit high, and all the other plots. All the plots for identifying how your data is behaving.
So it is suffering from overfitting. We
Yeah.
need to do some regularization.
Yeah. Yeah. So regularization and all you can't do here.
Okay.
Linear regression you can do.
Only linear regression.
Yeah, linear regression. Yeah.
Okay. And in the moving in that time series, only moving average, no whole winter, seasonal. Nothing.
Unfortunately, no. But if you know the equation, you can write down the equation in Excel and perform that analysis as well. You have the option of Fourier analysis, and exponential smoothing is there, but Holt-Winter
Uh,
is not.
okay.
Okay, you can try exponential smoothing,
Yeah.
but Holt-Winter is not there. Holt-Winter is fairly, again, very simple algorithm in itself as well.
Right.
But
Yeah.
yeah, so yeah, you can get all the information. So it gives you summary output, it gives you ANOVA output as well here. It gives you intercept and t-stat p-value, lower upper value, 95% confidence interval we have selected. It has identified this probability output as well, so you can see the residual plot as well, how much error you are getting, how much temperature residual plot, and line fit plot. So again, the predicted units and the units sold, basically you can see that these are initially very much in line, then there is one off here and there's a bit of off here. So these are the identifiers that you can see from the graph as well. And normal probability plot is like this, because it will be it will try to fit it in a straight line because it's linear regression. So yeah, these are the indication that you get, uh, and these are the information that you can show to your client as well. Again, this is very much variable one, variable two, because of labels that we didn't select. But here, if you select the labels, then you will get everything according to the label of your data as well, right? So everything, every information, basically they'll be interested to know what is your R square. So yeah, R square, and what is your standard error and things like that. So obviously this data is not, I mean, it's just for showcasing it to you. So that's why R square is very low, things like that. But yeah, you can see these things. You can identify these uh, graphs and see what are the notable changes that you see. Basically, this particular bit, price of ice cream, you can see that, yeah, there is a one off or two off, or things like that. You can compare the units sold and predicted units sold. Okay. And you can see that within the price of ice cream, which priced ice cream was number of units that was actually sold, and what was the predicted that linear regression gave. So that's a difference. That's the standard error that you can see within the error plot as well. Okay. So that's the residual plot. So it is a bit of a relation between these two. Sorry, this one, not the temperature one, this one. So this is having some relation. There's this residual here, and you can compare all the graphs. But yeah, and this is normality plot, which is giving you the indication that it is basically a linear regression, trying to identify one line of fit to find the predictions. Okay, so this was about linear regression. Any doubts on this one?
We have not work on multiple R. So this is also the matrices for regression problem.
Multiple R.
Yes.
Okay, this will come up when you will give your multiple. I mean, when you'll give multiple. What do you say? Multiple variables in your linear regression. Okay, so
Okay.
multiple
Okay.
R
Okay.
is nothing but again a KPI basically. It's nothing. Just basically like R square. So when you will see, it's basically a combination of R square and adjusted R square, I think. But adjusted R square is when you change an independent variable in your data. Okay, but here normal R square is basically giving you the value of the error difference between your actual and the predicted. But multiple
Mm-hmm.
R is it's basically a correlation coefficient, basically nothing else. And it basically uses the R square and adjusted R square value, and it gives basically a strength of relationship between the variables that you have. So it usually very much similar to coefficient of correlation, Pearson coefficient of correlation, but not exactly the same thing. It's just gives you this the relationship, how strong a relationship is. So whatever information you get from the R square and adjusted R square, uh, basically it's a combination of both. And if you have multiple independent variables, then you will get multiple R. in your regression statistics column, and it will just give the goodness of fit. How it will give you the higher the number is, the better the fit is, basically. Okay,
Okay.
that information it will give to you.
Okay.
Just like a coefficient correlation or coefficient, it gives you information about two different independent variables. This multiple R will give you information about the fit line, because it is captured from R square values. So it will give you how better your plot has been, how better your line of fit has been, how better your linear regression has been. That's all. One of the KPIs, that's all.
Okay.
Only possible when you're doing when you're adding multiple independent variables.
Okay.
Cool. Yeah, so that's it for regression. Any doubt on this one? Cool. So again, moving on to rank and percent. So this is one of the things that basically is used very. I won't say that it will be used very rarely, but it won't be used very regularly for sure. So when you go to data analysis, you will see rank and percentile. Okay, click on rank and percentile, select all the data, and so input range, just keep it if you want, you can put multiple rows as well, but if you want to see how rank is moving on for one particular column, you can select one. So just keep it for one, like let's do it for price, so B2 to B8, and if again B1 and labels in the first row, and again remove this and put it here, and then click on OK. It will give me the value. So point basically gives you the index number. Okay, so 10 is basically on top, so that's why 1 is at the bottom. 1 2 3 4 5 6 7. As obviously it's in descending order, in ascending order. So here it has reversed it in descending order, and it has given a rank 1 2 3 4 5 6 7. Highest number is assigned as 100%, and then subsequently the percentage value just reduces, and the lowest value is given 0%. So within that, the range of percent values, basically it's others are so other numbers are ranked, and this is percent, but it's
Numeric
actually
percentage, right?
it's not percent, actually it's percentile, but yeah,
We can say that
because
like 50% of the values are lesser than 30 rupees, right? Is that
yeah.
true? Okay.
Yeah, but like you can see it as an identifier to the rank. So suppose in cat exam, somebody who is rank 1 is obviously 100 percentile, right? And things like that. So who is rank 2 maybe is 99 percentile, but here in this case 83, and things like that. So it is just showing the percentile and the rank. So if you want to rank it, so things that you usually, these things you do in Python or SQL, you can use it here as used to do it here as well. So there's a rank function in SQL. You might be knowing that. It is the same thing which rank is doing in SQL. Same thing.
Okay.
Cool. Any doubts? Obviously, it will not give you dense rank. Obviously, it will not give you row number as SQL is giving. But yeah, if it's a normal rank function that you want to use, yeah, you can get it here. Cool. Now let's go to normal distribution. So it's not coming. Anyway, so normal distribution, plotting a normal distribution curve is a bit complicated in Excel. So it's better to just write 2 lines of code in Python. But yeah, you can do that here as well. So that's the thing. So for that, if you have a value, so suppose I've taken a value of 20 rows, okay, and I've given it an incremental factor of 10 points, so 10, 20 to 200, and I'm taking the mean of it. So if I'm taking the mean of A2 to A21, what I'm getting is 105, and it's basically the average. And then standard deviation I'm calculating. So there's the formula for calculating standard deviation. So there's a lot of things to learn in this one. So standard deviation is this STDEV, okay, and it is giving you A2 to A21. So there's a formula called standard deviation in Excel, which for which you can calculate the standard deviation using STDEV and then give the range of the values, okay, A2 to A21, and it will give you standard deviation. Okay. Now to identify a normal distribution curve, surprisingly, you have the formula norm.dist to get the normal distribution curve. What it means is it will try to identify a number for you based on the value which it is getting from the data set, and it will try to give you a normal distribution number from the very low numbers to the highest number, whatever it is present in your data. And then it will give you the value to plot a normal distribution curve. Okay. So now it is taking A2 as the reference, so mean X, sorry, as one data point. And then you have to give the mean. So, so X, so try to visualize it. So this is X1 and this is X20. So X1 to X20, what you are giving in the formula is X1, then the mean X bar, and then standard deviation, okay, as 59.160, okay, E3, and then the cumulative. So what is happening here is basically cumulative is basically trying to identify whether you're trying to give it a 0 or 1 basically. And when you see, it gives you the option of cumulative distribution function and false probability mass function. Okay, so if you select 0, it will give you probability mass function and your normal right now I'll delete it, I'll get to this point. Okay, and once you get this, okay, with this formula, and mind it, I have kept A2 unlocked, I've not locked it because again it has to compare the next data point in A3. So this is X2, and then again the mean should be the same. Okay, so that's why I have locked mean and standard deviation in the formula. Okay, dollar value is there, but not here. A2 and A3 is independent. So it will move as the rows go beyond the data points. So once you get one formula settled, click on the right hand bottom corner cursor. It will replicate every time. And you can see it will go from A2 to A21, but E2 and E3 will be constant everywhere. Okay. So my mean and standard deviation is constant. I've got the curve plot. Okay. And now you go to insert tab. Yeah, sorry. So yeah, so you'll get the data points for the curve. Okay. And you go to insert and you see a scatter plot option here. And just select this one and select the third option. And then you'll get the curve. So basically it's a normal distribution curve. You want to increase the size, you can see here. And yeah, if you want, you can create. So these are the tool tips that are coming up. So if you're clicking on if you're just hovering over this one, it is giving you the series curve and point as well. But if you want, you can just go and add data labels, and you can see that you get, if you're using a Windows version, you'll get a plus sign here, okay, at the right hand top corner, and there you will get the option to add data labels. And in Mac, you can right click or double click and then use it. You can add a trend line as well. It's a very straightforward trend line. And then when you add trend line, it will give you multiple options to play with the chart. You can fill color, you can increase the transparency and things like that. Okay. So these I leave it up to you. But yeah, main information is that you can plot a curve and a normal distribution curve in Excel as well. And this sometimes becomes very handy. But it's just that it's important to write down mean and standard deviation first to calculate. And then in the normal distribution curve, you will get the option of like checking your mean and standard deviation with the first data point to the last data point separately, and accordingly it will plot a normal distribution point so that you can plot a curve for it. Okay. Any doubts on this one? Cool. So, cool. So moving on to percentage difference. This is the final bit of data analysis. So percentage difference, as I was saying when in the beginning, this after in descriptive statistics, there are multiple things that are there, but not everyone will understand that. Most of the people will not understand that. Maximum, they will understand the maximum, minimum value, average value. They will understand correlation very well. But this is the other thing that they understand very well in industry, percentage difference, because it allows you to compare two different data. Okay. So what is happening here is it's just normal percentage difference formula, but it's important for your data analysis thing. So from rank and percent, you can see that I have kept it formula wise, normal distribution percentage difference. It is not related to data analysis tool pack. So these two are independent of that. But yeah, it is very important for your industry experience and if for your interviews as well. That's why I covered it. So percentage difference is something which people see, especially if you are tagged in a sales project or any project with a retail domain in retail domain. So they will try to compare it with previous values. So previous quarter, or maybe they want to compare two prices of revenue of two different products, things like that. So then percentage difference is very important. The only point is that we just have to be careful on the comparative point. So if I'm so you can see there's a price of ice cream, and then in C column new price is there, so change it, and then 10 is changed to 12, 20 is changed to 15, 25 changed to 10, 30 is changed to 32, and they want to and you want to compare these two prices. So it's important that you keep the new number first, and then negate it with the previous old value, and then divide it all together with the older value, and then it will give you the percentage difference. So obviously 12 minus 10 divided by 10 will give you 20%. The price has increased. Again, negative 25%, 60%, negative, and then again positive 7%, 57%, and negative 60% and 17%. Again, coming with the same formula. I haven't logged this, as you can see, because it has to do calculation on each row. So I haven't logged this. And this is one of the KPI that is heavily used in retail industries. They want to compare when they want to compare the two different values. So, and they understand correlation and percentage difference very well. So that's why I've kept this, so that you can use this and tell them in the interview that, yeah, this is one of the unique KPI that you use it to communicate with your clients. And this formula would, again, if they might and they might not ask, that's why I've explained this formula as well. It is not a rocket science, but then again, in the same case, they will ask you in every single interview that how do you communicate your data with your clients. So this becomes a handy tool to explain your information to them, right?